In this lecture, we are going to study about the Biot Savart's law and its application. We know that Coulomb's law in electrostatics was used to find electric field due to a point charge, which was a scalar quantity. Biot Savart's law gives us the formula to calculate magnetic field intensity due to a current element, which is a vector quantity. Are you following? Gauss's law tells us the rule to calculate electric field intensity due to a point charge, which is a scalar quantity. Charge is a scalar quantity, but Biot Savart's law helps us to calculate magnetic field due to a portion of the wire, due to a small portion of the wire called current element. And here the current element is considered as a vector quantity. So here we will just write, we'll just draw a diagram. Let us say this is a wire, and this wire is say carrying a current I. And due to this wire, I need to calculate magnetic field at some point. So what we do, we divide the wire into small pieces. I'll consider a portion of this wire which is carrying current. Let me consider a portion of this wire which is carrying current, and that is called as a current element. And here, the length of that current element is say DL. What is the length of the current element, people? DL. And we are assigning a vector over it. We are considering the current element to be a vector quantity, DL vector. And the direction of DL vector is along the direction of current. What is the direction of DL vector? It is along the current. And let us say we need to calculate the magnetic field at this point P due to this current element, due to this small element, we need to calculate the magnetic field. So what I will do is, first I need to mark the vector in the direction of current, which is called as the DL vector. This is called as what? That small portion of the wire which is carrying current, that is called as a current element. That is called as what? That is called as a current element, and it's a vector quantity. And I have to calculate magnetic field at this point. Magnetic field at P I have to calculate due to a section of the wire, due to small section of the wire. So the magnetic field that will be produced is a small magnetic field, which I can denote by dB. And the position vector of this P with respect to this current element, let me call it as R vector. I'll draw a vector considering the current element as the origin, considering the current element to be at the origin. I'll draw a vector. I'll draw a vector from the current element to point P, and I'll call that as say R vector. The distance is R. Now, the magnetic field at P due to this current element, as we know that current carrying wire is a source for magnetic field. So how much amount of magnetic field is this current element going to produce at P? So that we can write it as a dB, and it is found that it is proportional to the strength of the current. More is the current you pass through the wire, more will be the magnetic field. It is found experimentally. It is found experimentally that the strength of the magnetic field is proportional to the amount of current you pass. It is also proportional to the length of the current element. More is the length of the current element, more will be the magnetic field. It is proportional to sine of the angle between the current element vector, DL vector, and R vector. This is my theta. Theta is angle between whom? Theta is angle between DL vector and R vector. It is the angle between the current element and the line joining the current element and point P. This is my theta. So dB is found to be proportional to sine theta, and it is found to be inversely proportional to R square, like Coulomb's law. Coulomb's law is it obeys inverse square law. Same thing, magnetic field, this Biot Savart's law also obeys inverse square law. As you increase the distance, magnetic field is going to decrease. Now, combining all these things, combining all this, we get dB is proportional to I into dl into sine theta divided by R square. And if I remove the proportionality sign, I introduce a constant. If you remember in electrostatics, what was the constant K? K was equal to 1 by 4 pi epsilon naught, isn't it? Epsilon naught is the permittivity of free space or vacuum. 1 by 4 pi was there. So here the constant will become mu naught by 4 pi. What will the constant become, people? Mu naught by 4 pi. 4 pi is as it is there. Just that this 1 by epsilon naught is becoming mu naught. 1 by epsilon naught becomes mu naught, or epsilon naught becomes 1 by mu naught. 4 pi will be as it is. Mu naught by 4 pi, I into dl into sine theta divided by R square. This is the formula. And what is this mu naught? Mu naught is nothing but epsilon naught was the permittivity of free space. Similarly, mu naught will be the absolute permeability, or we can call it as the permeability of free space or vacuum. Of free space or vacuum, whose value is equal to 4 pi into 10 power minus 7 in SI units. So in SI units, the value of mu naught is going to be how much? 4 pi into 10 power minus 7. And what does mu naught indicate? Epsilon naught indicates the ability of the vacuum or the air to allow the passage of electric field lines through it. Similarly, mu naught indicates the ability of the vacuum or air to allow the passage of magnetic field lines through it. That is the meaning of mu naught, and the value is 4 pi into 10 power minus 7. This is in the scalar form, and we have already seen the direction. We can use right hand thumb rule or right hand clasp rule. We can use to find the direction of magnetic field. In the vector form, how do we write the Biot Savart's law? In vector form, we write the Biot Savart's law as we know the current is a scalar quantity. So you just keep the current outside, mu naught by 4 pi I. I'm going to multiply and divide by R because R is a vector quantity. R and DL both are vectors. So I'm going to multiply and divide by R, DL into R into sine theta. I'm multiplied by R and I'm going to divide by R. R square into R will become R cube, isn't it? Now this matches with A, B sine theta, isn't it? Which is nothing but A cross B. In the vector form, the magnitude of A cross B is what? AB sine theta. So I can write DL R sine theta in the vector form as DL cross R divided by R cube, isn't it? Therefore, DB vector is equal to mu naught by 4 pi I into DL cross R vector divided by R cube. This is the Biot Savart's law in vector form. In vector form, Biot Savart's law is given by mu naught by 4 pi I into DL vector cross R vector divided by magnitude of R cube.